Hey guys, welcome back to another video. Today is a special video because we have got ourselves the Feb-March 2022 papers that were just done a week ago, and we managed to get these papers. If you want the papers for yourself in a PDF form, you can message me on Instagram. I don't want to leave it down in the description because again it's too early, but again after some time I will leave it down in the description. But for now you can message me on Instagram and I will give it to you as fast as possible. Okay, with that being said, today we are going to have a look at the MCQ paper 2.2 for the Feb-March that was just done. And just a disclaimer, there's no marking scheme for this paper currently, so far these are all my answers. So if there's any mistake, I apologize in advance, and if there's any mistake, please do comment down below, and if it's valid then I will respond to that and even pin it if that is correct. But I'm hoping there is no mistake. I've gone through this a couple of times, so hopefully there is no mistake. With that being said, let's just get on with this video. The first question: which gas has the fastest rate of diffusion? Okay, so whenever we're looking at diffusion, we have two factors. Okay, one of the factors is temperature. Okay, the second factor is the RAM, or the mass of the molecule. So in this case, the best one would be the mass of the molecule, isn't it? Okay, so if I calculate the mass of the molecule for each of the following, right? If I calculate the mass for hydrogen, it will only be 2, which is 1 plus 1, because hydrogen has a mass of 1. For CH4, carbon has 12, isn't it? And hydrogen has 1, so 1 times 4 is 4, so this one will have 16. So this is already too heavy. 6 CO2, C has 12, O has 16, so it will be 32 plus 12. 32 plus 12, if I use my calculator, is 44. Okay, 44. Okay, so that again is already out, and I believe sulfur has 64. I don't have the periodic table, neither is it attached to this document, but I'm sure it is heavier than hydrogen. So the answer for this one is hydrogen, and the reason to this is because it is the lightest from all of them. Okay, and if it is lightest, then it can travel the furthest, because diffusion is about spreading out. Okay, so because it's the lightest, it will spread the furthest, and therefore the answer is Ca, which is hydrogen. The next question: in which state does 1 dm cubed of methane contain the most particles? Okay, so we have three states that we know, which is gas, liquid, and the solid. And we all know that the solids, basically the particles are the closest together in this structure, because we know it's in a regular structure and it's all arranged. So therefore the one with the most particles would basically most meaningly be a solid, and hence the answer should be a solid. It can't be a gas, as I told you. It can't be a gas because gas is spread apart, and especially if it's at 100 degrees, it has enough energy to keep moving around and even expand more. Okay, so this one should 100% be wrong. Neither can gas at room temperature even work, neither can liquid, because liquids do move around and bounce on each other. We move on to question 3. Question 3 says, which statement explains why isotopes of the same element have the same chemical properties? What is an isotope? An isotope is basically an element with the same number of protons, a different number of mass number, or a different number of neutrons. And we know for an isotope, they have the same chemical properties, and the reason to this is because of the electrons, because they have the same number of electrons in the outermost shell. So anything related to electrons would be correct. And I can already say A is saying they have the same electronic structure, and hence that should be correct. So A, they have the same electronic structure. Electronic structure basically shows the number of electrons. Relative mass, I said in the definition of isotope, it has a different mass, so this is wrong. They have the same nuclear number. This nuclear number is the same thing as mass number, so this is wrong. They have the same proton number. Now they do have the same proton number, but the proton number does not contribute to the chemical properties. Proton numbers do not contribute to chemical properties, so therefore this is wrong. Number 4, it says the electronic structures of atoms P and Q are shown. So we have P right here, and if we just write the electronic configuration, it will be 2, I believe 1 to 6, isn't it? 6, and this one would be 2, 8, 1. Okay, so we have 2, 6 and 2, 8, 1. This is of course an ionic compound. An ionic compound is one that is a metal this is a nonmetal, one is a nonmetal, and one is a metal. This is a metal, this is a metal in group 1. Okay, I know why it's a metal, because of the last one. It's 1. If it's 1, meaning it's in group 1. Here it's in group 6. So it's telling us what is the formula. This is quite simple. This one has a charge of 2 negative, because to become an octet state it has to gain 2, so hence 2 negative, and Q has to lose 1 electron, hence positive 1. Okay, so therefore the formula would be PQ2, because this one will be transferred here, this one will be transferred there. So therefore PQ2, the answer should be D. Move on to the next question. Fermentation of sugar produces a mixture of ethanol. Okay, so this is a mixture. Keep in mind, this is a liquid and solution, and a solid yeast. So this is a solid. How is the solid yeast removed from the mixture? So we have a solid, right, and we also have a liquid, and we know with the help of our skills on separation, we know that filtration indeed is used to separate a solid from a solution, and hence the answer should be filtration. Move on to the next question. The next question is telling us about which rows explains why copper is a good conductor. We all know copper is a good conductor, but what is the reason to why they have a good conductor at room temperature, or why is copper a good conductor of electricity at room temperature? So first of all, we have the ions, we have the electrons. Okay, now one reason why it's a good conductor, it's because electrons are free to move. We all know that electrons are free to move, right? Because electrons are free to move, then they are most likely, it's either this. Now, okay, now what happens to the ions? We all know that ions vibrate, don't they? But when do they vibrate? They vibrate when they get energy. But at room temperature, do they get energy? They don't get energy. So hence the copper ions do actually move freely, but they do not move freely when it is at room temperature. So the answer should be B. Now again, it could be controversial, because some people would say the copper ions would vibrate more, okay, which would mean that is why it is a good conductor. But my case is because it's a room temperature, the ions cannot vibrate, isn't it? Because we know that the ions vibrate only when they get enough energy, and the reason they get enough energy is through the help of temperature, which is basically kinetic energy. So hence the answer should be B, because ions should not contribute. Even though ions could be one of the factors, it's not in this case. We move on to number 7. Number 7, it tells us which pair of statements about diamond and graphite is correct. So we know diamond and graphite, these are called large macromolecules. Okay, so diamonds and graphite are called large macromolecules. Okay, so with that being said, we have some options and it's telling us which one is correct. Let's see. Diamond and graphite are both pure carbons. Yes, they're both pure carbons. We know them as both made up of carbons, and they both are macromolecules. Yes, so the answer for A is correct. But let's have a look at the other answers. Okay, let's move on. It says the diamond and graphite can be used as electrodes. Have you guys seen diamonds as being used as the electrodes? No, that's not being used as the electrodes, because diamond has no conductivity. It is a bad conductor of electricity, and we should know that electrodes help, you know, it's basically electrolysis, and it's the usage of electricity. And if the the electrode cannot conduct electricity, then electrolysis will not work. But the second statement, it is used as a lubricant, is correct. Okay, it is used as a lubricant because it can slide past each other. Molecules can slide past each other. See, diamond has covalent bonds, graphite has ionic bonds. That is, diamond does have covalent bonds, but graphite does not have ionic bonds. It has covalent bonds. We all know that it has strong covalent bonds, hence they have a higher melting point because of the long carbon chain, okay, which contributes to that. Diamond is hard, as a high melting point. That is correct, because of the long carbon chains. Graphite is soft with a low melting point. Now graphite is soft, isn't it? But it does not have a low melting point. Because of the carbon chains, it has a high melting point. So that is wrong. So therefore the answer is A. Sodium nitride contains the nitride ion N3-. Okay, sodium nitride is an unstable and decomposes into its elements. Okay, Now, what is the equation for a decomposition of sodium nitrate? We know decomposition, we always have one reactant and products, of course, will be as many as they are. Okay, so in this decomposition reaction, okay, if you don't have an idea to how this equation looks like, you have to be quite smart. If you notice in all these, right, we have either 2Na or 2Na3. Okay, those are the two possible ways. We know with the help that because it is 3 minus, okay, because nitrogen is 3 minus, therefore sodium has to have a 3 here. Sodium has to have a 3 here, so it's either this one or this one, isn't it? So it's either B or D. Now maybe you don't know what the products are, but no worries, because we can look at the balancing. Here we have 6 sodium, here we have 6 sodium, so that's correct. But here we have 2 nitrogen in this type of form, and we know nitrogen is actually a diatomic molecule. We know nitrogen is a diatomic molecule, and hence it cannot be looking like this. So hence the answer should be B, right? So the answer is B. Move on to the next question. So it says compound X contains carbon, hydrogen and oxygen. By mass, it contains 26.7% of carbon to 22.2% of hydrogen. So how much carbon is there? Carbon we have 26.7, hydrogen we have 2.2. How much oxygen we have? We don't have the oxygen, so we use our calculator. We will add 26.7, we will add 2.2, and we'll do 100 minus that. So that will give us 71.1. With the help of this now, to calculate empirical formula, I need to first divide by the total RAM. So for carbon it's 12, hydrogen it's 1, oxygen it's 16. What will all this give us? Let's see. So 26.7 divided by 12 will give us 2.225. Okay, so let me just write it here, 2.225. For this will be remaining 2.2, and for oxygen 71.1 divided by 16 will give us 4.4. okay, so now if I divide everything by 2, okay, this divided by 2 will equal to 1, this will of course equal to 1, and this 2.2 will equal to 2. So the answer will be CHO2. That is the answer. Hence I can see this is CHO2. So that is the answer. Move on to the next question. The next question is saying cesium fluoride is an ionic compound. What do we know about ionic compounds? I think it's about a question on that, and I will tell you what we know about ionic compounds. Now, which statements about cesium fluoride are correct? Okay, which statements about the cesium fluoride are correct? It conducts electricity when solid. No, it does not conduct electricity when solid, because we know when it is in liquid, it's the only way it can conduct electricity, because the electrons are free to move and hence they can conduct electricity. And that's the reason why in electrolysis we have the molten form and not the solid form. Okay, so we know in the definition of electrolysis, it is the separation or the breakdown of ionic compounds. Okay, and we know the ionic compounds, right? They indeed can only conduct electricity when they are a liquid or in molten form, isn't it? So therefore this would be wrong. It has a high melting point, that is right. Okay, and that is the reason why we use something called the cryolite in electrolysis. The cryolite lowers the melting point, but in nature the ionic compounds have a high melting point, so 2 is correct. They have again a high melting point because of the strong electrostatic force between the ions. Now, are they soluble in water? Yes, they are soluble in water. We all see that in electrolysis. They are soluble in water. They are soluble in water because the water molecules have a stronger attraction to these ions in the ionic compound. Highly volatile? No, they are not highly volatile. They are less volatile. So the answer should be 2 and 3. So the answer is 2 and 3. Move on to the next question. Which diagram shows the direction of movement of ions and electrons during electrolysis of the molten sodium chloride? So let's see. First of all, we need to know the cathode, okay, takes which ones? They have the metals and the hydrogen, isn't it? While the anode always has the halogens, right? The halogens like chlorine, fluorine, bromine, and has the nonmetals and has the oxygens. Okay, so this is some quick thing you can remember. So let's see. So the anode always has to have chlorine, like this one can be a possibility, or this one cannot be a possibility. This one could be a possibility. This one cannot be a possibility. Anode, chlorine, yeah, this could be a possibility. So it's A or D because chlorine has to be in the anode. Next up, the cathode, it has to be leaving, it has to be entering, it has to be entering, the current has to be entering, okay? And for anode, leaving, because it's a positively charged electrode. This is negatively charged, so it has to be entering. So the answer should be A. Okay, so the answer is A. Move on to the next question. The next question is telling us calcium carbonate, which is CaCO3, reacts with dilute hydrochloric acid to produce carbon dioxide. Okay, so this hydrochloric acid is giving us CO2, like this right here. Okay, the equation is shown here, and the relative formula mass, so that is the RFM, is 100. Okay, and it is telling us 10 grams of calcium carbonate is reacted with excess. So first things first, we need to find the moles, because most likely it's telling us how much CO2 is produced. So how much is this produced? So we need to find the moles so that we can compare the mole ratio, and in this case the mole ratio seems to be 1:1. Okay, so that doesn't matter. So let's calculate the moles. We know the formula for moles. It is the mass. Moles is equals to the mass over the RFM. And we have both, right? We have 10 and we have 100. So this will give us 0.1. Now we need to find the RFM for CO2. So CO2, the RFM, carbon is 12, oxygen is 16. So 16 times 2 is 32. So 32 plus 12. 32 plus 12 is 44. So 44 times 0.1 will give us 4.4 grams. The answer should be 4.4 grams right here. Really easy, right? Really easy. Okay, we move on to the next question. Let me just quickly rub this in case we need it. Okay, the next question. Molten sodium chloride, okay, molten form again, and concentrated aqueous sodium chloride are electrolyzed using the platinum electrodes. So you need to know that you can use either carbon electrodes or platinum electrodes. Any of them works. So then it's telling us what are the products at the negative electrode. So this is the cathode. Okay, the negative electrodes, usually we told you it's hydrogen or is the metals. So hydrogen is used actually in molten sodium chloride and also in concentrated. So the answer should be A. Okay, molten sodium chloride and concentrated aqueous sodium chloride. Move on to the next question. This is about electroplating. We all need to know before even reading this question, for electroplating, the object that is to be electroplated always has to be in the cathode, and the other one is the material that's used. Okay, so let's see. An object is electroplated with silver. So silver should be in the anode, isn't it? Silver in the anode, because this will actually electroplate the cathode. Okay, so hence the object to be electroplated should be the cathode side. It's always cathode, and the electrode should be made up of silver. It can't be carbon. Where is carbon coming from? Because, you know, yeah, maybe carbon is, maybe some people can be confused because of the other electrolysis, but it's actually silver. Okay, because it is electroplating, not the normal electrolysis, isn't it? The next question, which row describes the changes that occur in an endothermic reaction? What is endothermic reaction? It's taking in energy, isn't it? So that's the first thing we need to know, taking in energy from the surroundings. So let's look at that one. So it's either C or D, right? It's because it's taking in the energy. And then next up is the temperature will always decrease in endothermic. So in any endothermic, the temperature will decrease. Okay, temperature is decreasing. For exo, the temperature will increase. So for exothermic, temperature will increase. For endothermic, it will decrease. So the answer for this question is actually this. So this is the answer. We move on to the next question. The next question is talking about which statement about the fuels is correct. So which statement about the fuels is correct? So let's see. First of all, heat energy is only produced by burning fuels. This is wrong. It's incorrect. Heat energy can be produced in many other factors. If you do physics, you know that heat energy could be released by anything. Okay. Hydrogen is used as a fuel, although it is difficult to store. That is correct. Now, the reason to why it's difficult to store is because hydrogen, okay, we all know hydrogen has a low density. Okay, it has a low density, and because it has a low density, it is very light. And because it's very light, it's very difficult to store, because how will you store a gas that is this light? Okay, that's the reason why we use hydrogen. Okay, let's look at the other options. Methane is a good fuel because it only produces water. It does not only produce water, it actually also produces carbon dioxide, right? It also produces carbon dioxide and water. Okay, this is only when it's the hydrogen fuel cell. Hydrogen fuel cell is hydrogen plus oxygen, isn't it, to form energy, which is the product is only water. Uranium is burned in air to produce energy. This is wrong, because uranium reacts with the atoms and splits apart to form the energy. That's the reason why it does not react in air, isn't it? Let's move on to the next question. Which statements about the endothermic and the exothermic reactions are correct? Okay, so which statements about endothermic and exothermic reactions are correct? So let's see. In an endothermic reaction, less energy is absorbed in bond breaking than is released. Actually, it's the opposite. It is more energy is absorbed in bond breaking. Okay, so when the bond is breaking, it's more energy, okay, than is released in the bond forming. So this is the opposite. In an endothermic, the activation energy is always higher. In exothermic, that is nope, that is wrong. In an exothermic reaction, more energy is absorbed in bond breaking than again, this is the opposite. In an exothermic, it's less energy is absorbed in bond breaking and is released in bond forming. So the last option is correct. In an exothermic reaction, the reactants are higher on the energy level diagram, and that is correct, because when we draw the energy level diagram, this side, okay, is the reactants, okay, this side right here is the product. Okay, this is for an exothermic reaction. For the endothermic reaction, it will be like this. Okay, this is where the reactants are and this is where the products are. So the answer should be D. Okay, we'll move on to the next question. The reaction used to manufacture ammonia from nitrogen and hydrogen is reversible. Okay, we know this. This is called the Harbour process. An equilibrium is established between ammonia, nitrogen and hydrogen. What does equilibrium mean? Now this is really tested in the paper 4 question, so you need to know this, because equilibrium is when the rate of forward reaction equals to the rate of backward reaction, and as well as the reactants in the product are constant. So we're looking for something like that. So let's see, both the forward reaction and the backward reaction have the same rate. That is correct. Let's look at the other options. The rate of the backward reaction is greater. No. The rate of the forward reaction is greater. No. This could only happen when there are factors like temperature or pressure. Okay, like those questions are tested in paper 4. The forward reaction and backward reaction have both been stopped. That is wrong. That is not a reaction, isn't it then? How does increasing the concentration affect the reacting particle? So increasing concentration will increase the collision rate, because we know it's a factor affecting a reaction, but the activation energy, nothing happens. So the answer is A. Okay, so it will increase the collision rate, but it will not do anything to the activation energy. Okay, so the answer should be A. We move down. Okay, methyl orange is a universal indicator, we know that, or is an indicator actually, not universal, but is added to a dilute hydrochloric acid and to aqueous sodium hydroxide. What is the color of the methyl orange in each solution? So we know for methyl orange, and we know this because of titration, methyl orange turns in bases, it turns yellow, okay, and in acids it turns red. So we're looking for something like this. Hydrochloric acid is an acid, sodium hydroxide is a base, so we're looking for base yellow, this acid. So the answer should be B, because it's a red in an acid and yellow in a base. It's always like that. Okay, so you need to know this. If you focus on your practicals, you would get it. Now I'm sorry for skipping question 2.1. It seems like the picture taken for this examination was cut out the question, so unfortunately I will not be able to do question 21. So for now, just ignore that for now. But hopefully when it's officially released, you can go over this question. We move on to question 22. Information about some silver compounds is shown. Okay, so we have these 4 compounds and the formulas and the solubility. Okay, it's telling us which equation shows the reaction which cannot be used to make a silver salt. Now already I know, first of all, we can look at the reactivity, okay, and the solubility, and they've given us the solubility. With a reactivity, you need to know the reactive series to understand how reactivity works and to understand how equations work. Okay, reactivity series is really important. You need to memorize your reactivity series before going to any of these chemistry exams. Okay, so let's see. Now, when silver nitrate reacts with hydrochloric acid, it does actually form silver chloride, which is a salt. So this is correct, isn't it? Okay. Silver oxide reacts to nitrate, which will also form silver nitrate, which is actually a salt too. Okay, silver carbonate plus nitric acid will actually also form silver nitrate, which is an acid. So this should be the answer, because silver and hydrochloric acid cannot form silver chloride, because silver we know is in the bottom of the reactivity series, and silver is less reactive than hydrogen. Okay, hydrogen is more reactive than silver, isn't it? So hence this reaction is not possible. Okay, it cannot form a compound when it is less reactive than hydrogen, isn't it? So that is wrong. We move on to the next question. Aqueous ethanoic acid is a weak acid, so it's even telling us it is a weak acid. Okay, and aqueous sodium hydroxide is a strong base, so it is a strong base. You need to keep that in mind. Okay, aqueous ethanoic acid is neutralized by the aqueous sodium hydroxide. Which statements are correct? Let's have a look at this. Aqueous ethanoic acid accepts protons. We know acids actually donate protons, they don't accept protons, so this is wrong, isn't it? The aqueous ethanoic acid is fully dissociated into ions. Now this only works when they are strong, but you can even tell here it's saying it's a weak acid, so this is wrong. Aqueous sodium hydroxide is used to fully dissociate into ions. This is correct because it is a strong base, hence they can dissociate into ions. The reaction produces salt and water. That is also correct because it is weak acid, strong base, neutralization, hence salt and water. The answer should be 3 and 4. Move on to the next question, number 24. It's telling us 3 properties of element X are listed. It contains in atoms with the full outer shells, for example 2,8, 2,8,8, something like that. Monatomic, like group 8. So these seems like this is all group 8. Unreactive, group 8. So the answer is group 8. This is group 8. Move on to the next question. Which word equation represents a reaction that occurs? Okay, so which word equation represents a reaction that occurs? So again, this one we look at the reactivity series, okay, and the one that's more reactive will form the compound. Sodium plus carbon dioxide. This is wrong because sodium is more reactive than carbon, so hence it can't be this. It can't be carbon dioxide. Sodium oxide plus iron. This is also wrong because sodium is more reactive than iron, so this is wrong. Iron oxide plus copper is this, but actually iron is more reactive than copper, so this is also wrong. Iron oxide plus carbon, iron plus carbon dioxide. This is correct because carbon is more reactive than iron, hence the answer should be D. And this again, you need to know your reactivity series to understand this question. Next question. Which statement about the extraction of aluminium is correct? Aluminium we know is the extraction with aluminium and oxygen, aluminium at cathode, oxygen at anode. Okay, aluminium is formed at the cathode during electrolysis. That is correct. Already I know that is correct. We move on to the next questions. Hematite is mainly an aluminium oxide. So it's not hematite actually, it's bauxite. Okay, hematite is for iron if you remember. Okay, so you need to know this. So this is for iron. Molten cryolite is used to raise the melting point. It's actually the opposite. It's used to lower the melting point. Okay, so it's used to lower the melting point. So hence this is wrong. Even this is wrong. Okay, oxygen gains electrons. No, it loses electrons. Okay, loses electrons. Okay, aluminium gains electrons. So hence the answer is A. The metal M is mixed with copper to produce brass. We know brass. Okay, brass is made up of zinc and copper. So the answer should be zinc right here. So the answer right here is zinc. Move on to the next question. The table gives some properties of an element. Okay, what can we get to know about this table? First of all, we can see the melting point is really high. Okay, appearance, it has dark blue, meaning it's colored. Okay, has a high density and good conductivity. It means it is a transition metal. Okay, that's first step we have done. We have found out it's a transition metal. After it's a transition metal, we know that this acts as a catalyst. We know all transition metals act as a catalyst. So that's the answer. Move on to the next question. Ammonia is produced using the Haber process. Okay, Haber process to form ammonia from nitrogen and hydrogen, which shows the source of raw materials. Okay, so nitrogen, we use fractional distillation. So fractional distillation of liquid air. So the answer should be air. And hydrogen, we use electrolysis or hydrocarbons, isn't it? So the answer is these ones. And the temperature has to be 450. So it's either these two now. And the pressure is 200. Okay, so the answer should be C. When the pressure is 2 atmospheric pressure, it is actually how we produce sulfuric acid. If you guys know that the sulfuric acid, it's the contact process. So the only way when we use pressure 2 is the contact process. Okay, so that's how you know this. Number 30, how many species are acting as bases in the reversible reaction? So it's a reversible reaction. This right here is an acid. Okay, we know this, nitric acid. This right here will react as a base, okay, to form an acid and to form a base. So that means there are 2 bases. So the answer should be 2. Move on to the next question. This is the contact process. I was talking about this just some time ago. So the contact process. Okay, what about the contact process? The contact process, what is the catalyst used in this contact process? Is vanadium oxide. We know this, vanadium oxide. Okay, it's vanadium oxide. Iron is used for Haber process. Haber process. Phosphoric acid, this one not needed. Okay, which information about carbon dioxide and methane are correct? These are both greenhouse gases. Greenhouse gases. They're both the greenhouse gases, hence both of them are correct. So the answer is greenhouse gases. Methane is not produced in respiration, present in unpolluted air, no. Formed when vegetation decomposes, no. So the answer is B. Okay, the structure of an ester is shown. Okay, so this is an ester. We know how esters are formed. It's when carboxylic acid and an alcohol react together. It's telling us what are the names of these carboxylic acids and the alcohol which react together. So let's first draw the acid, isn't it? Now you can see right here it has 2, isn't it? So it has to be ethanoic acid. So let's draw ethanoic acid. Ethanoic acid should have 2 carbons, and then have a hydrogen here, have a double bond oxygen here and here, and then should have a hydrogen here and a hydrogen here. That is how you draw ethanoic acid. Okay, this joins with propanol. It can't be ethanol because it has 3, so propanol. So how to draw this is just drawing propanol, quite simple. Okay, so this has the hydrogen bonds. Okay, this is how you draw propanol. So this joins together to form ethanoic acid and propanol to form that ester right here. The ester linkage we know is this is the ester linkage. Okay, we move on to the next question. Number 34, which statements about lime are correct? Okay, which statements about lime are correct? Let's start off. It's saying lime is made by heating calcium carbonate. That is correct. Lime is made by heating calcium carbonate, and I believe in one of the paper 4 questions, a whole entire question came on this, so you need to know this. Lime is used to desulfurize flue gases. That is correct. It's actually a very popular usage of lime. Lime is used to treat alkaline soil. That is wrong. It actually is used to treat acidic soil. Okay. The chemical name for lime is calcium oxide. That is correct. So the answer is 1, 2, and 4. That is B. Move on to the next question, number 35. Number 35, it says, what structure is correctly named? Let's see, ethanoic acid. Okay, it has 3 carbons, so it's wrong. It has to have 2 carbons, isn't it? We just drew it up here, and we drew it with 2 carbons, so that is wrong. Let's see, ethene, it has no double bond, so it's wrong. Ethanol, yeah, it's correct. This one's correct. Propane, it's an ane, so it can't have a double bond, so this is wrong. So the answer is C. 36, the structure of part of a polymer is shown. So this is the polymer. It says which monomers could be made from this. So we know this is repeating units of this. So as you can see, it's just repeating units. So hence, of course, the first repeating unit has to have this. Okay, so which one has this? It has to have, of course, a double bond. So 2 has to be there. 2 has to be there because it's exactly that. Now you can switch this and it will not affect. So this is also correct. So 1 and 2 is correct. It's monomers or polymers. you know, in this case is just repeating units. So you just need to look for the repeating units, you need to find the pattern, identify, and that's how it is. It's quite simple. Carboxylic acids are made by the oxidation of alcohols. We know that. The carboxylic acid is used to produce this. So you can see it has two carbons meaning ethanoic acid. It's as simple as that for the acids, isn't it? Ethanoic acid. We move on to the next question. Number 38 is telling us propene, okay, which is C3H6, reacts with bromine in an addition reaction, okay, addition reaction. Which structure represents the product of this reaction? So let's see. Here we only have one bromine, so this is wrong. It has to have two bromines. Here the bromine is on the same carbon bond, so it's wrong. Here the bromine makes sense. Here bromine cannot be on the edges, so it is wrong. So the answer is C. Number 39, which statements about ethanol are correct? Ethanol is used as a solvent. That is correct. Ethanol can be made directly from ethane. No, because ethane needs to be converted to ethene, and then ethene could be converted to ethanol. So this is wrong. And ethanol is a covalent compound. Ethanol is a covalent compound because it is C2, I believe. C2H4, isn't it? OH or something like that. Yeah. So it is. It has carbon, it has hydrogen, and it has oxygen, which are all covalent. The answers are 1 and 3. Okay, we move on to the last question. Which diagram shows nylon? Nylon has an amide linkage. Because it has an amide linkage, we're looking for either this, and this is not an amide linkage. This is an amide linkage. This is not an amide linkage. Not an amide linkage. Not an. This is ester linkage actually. So this is wrong. So the answer should be C. So there you go. That marks the end of today's video. Again, if there is any mistake, because I do not have the marking scheme for this, actually the papers are not even released. So if there is any problem, do comment down below. I am again apologizing if there's any mistake. I'm hoping there's no mistake. But with that being said, thank you guys for watching this video, and I will see you in the next video. Goodbye, everybody.